The iron grip of causality, defining hard determinism. We walk through the world clutching an illusion, the idea that we steer. Every morning we feel the weight of choice, coffee or tea, stay or go, speak or remain silent. This internal narrative of agency is the bedrock of our personal reality, the engine that powers our ambition and fuels our regret. But what if the steering wheel isn't connected to the tires? What if the path we believe we are designing has already been carved millennia ago by an inescapable geometry? We are about to look behind the curtain of existence, into the mechanism that dictates not just the movement of stars, but the firing of every neuron in your brain. Our theme is not simply fate, but necessity, the cold, indifferent logic that underlies all phenomena. We begin with the foundation, the principle that has guided science and philosophy for centuries: causality. The world we observe is not arbitrary. It operates via an infinite chain reaction. Every event is the effect of a prior cause, and that cause, in turn, is the necessary effect of an even earlier condition. This is the operating system of the cosmos. If you introduce a system, say a vast cloud of gas, a complex ecosystem, or the shifting mass of the entire observable universe, and you know the initial conditions perfectly, the laws of physics demand that you can calculate the exact trajectory of every particle forever. No event is truly spontaneous. Nothing leaps into being from a vacuum. Everything is necessary. This concept, universal determinism, holds that the state of the universe at any one moment strictly dictates the state of the universe at every subsequent moment. The future, in this sense, is already stored in the present, encrypted by natural law. The sun rises not because it chooses to, but because gravity and momentum compel it. The rock rolls down the hill not due to volition, but due to topography and mass. And we, the observers, composed entirely of matter, obeying these same laws. Do we truly possess an exception, a magical gap in the causal chain? If we accept the premise of perfect causality, that the state of the universe at t-1 rigorously dictates the state of the universe at t, we arrive inevitably at the central, uncompromising conclusion of this perspective. This is the definition of hard determinism. It is not a gentle suggestion. It is an iron grip. Hard determinism asserts two things simultaneously and unyieldingly. First, universal determinism is true. The causal chain is absolute, reaching down to the quantum level and extending out to the limits of space and time. Second, because the causal chain is absolute and exhaustive, human free will is, definitively, an illusion. The term hard signifies the incompatibility. It is the uncompromising assertion that if the physical laws govern everything, including the biological and chemical processes underlying consciousness and decision-making, then genuine, uncoerced choice cannot exist. The moment you perceive a choice, that moment itself is merely the necessary output of a complex biochemical calculation, a confluence of genetics, lifelong environment, sensory input, and the pre-existing architecture of the brain. When you choose the apple over the orange, that preference wasn't conjured spontaneously. It was the inevitable and necessary result of the specific configuration of atoms in your head at that precise moment. To hold an incompatibilist view, as the hard determinist must, is to stare into the abyss of non-agency. Everything we do, think, or feel is determined by factors originating long before we were born, factors utterly beyond our control. Our feeling of authorship is a powerful, persistent fiction generated by the very machinery that is, itself, governed by external forces. The great 18th century thinker Pierre-Simon Laplace famously described this perspective. He imagined an intellect vast enough to know, at a single instant, all the forces that animate nature and the relative positions of all things composing it. To such an intellect, Laplace argued, nothing would be uncertain. The past would be visible, and the future would be equally present to its eyes. This conceptual intellect, often called Laplace's demon, is the ultimate expression of hard determinism. If the demon exists, your next word, your next thought, and the ultimate moment of your death are already solved equations. Hard determinism strips away the idea of the self as an independent, originating source of action. The future is fixed. It is not just predictable, it is already settled. The journey is mandatory, and the destination is guaranteed. This realization forces us to confront the deepest challenge to our sense of self. If our choices are predetermined, then who is responsible for the ensuing consequences, and who or what is really driving the canvas of thought? This is Demon, the myth of perfect prediction. For centuries, the mechanical logic of the demon offered an elegant, terrifying simplicity. The universe is a vast, self-solving equation. If this were true, our lives are not defined by choices, but by consequences. Our deepest longings, our most unexpected triumphs, our very sense of self, all would be mere optical illusions, the inevitable result of forces set in motion during the first nanosecond of the Big Bang. We become nothing more than complex billiard balls rolling across an infinite table, believing we chose the pocket, unaware that the angle, the force, and the felt grain were all predetermined. Free will, under the gaze of Laplace's architect, would be the most convincing fiction ever devised. This deterministic vision dominated scientific thought, shaping our understanding of fate and responsibility until the mid-20th century. That is when the perfect architecture of existence began to show its first cracks. The first challenge arrived not from a philosophical treatise, but from the simple complexity of weather. In the 1960s, meteorologist Edward Lorenz introduced the world to what we now call chaos theory, symbolized by the butterfly effect. Lorenz discovered that in complex, nonlinear systems like the atmosphere, an infinitely small change in the initial condition yields a massive exponential divergence in the outcome. The demon requires infinite precision to forecast the future, but the physical world denies us infinite precision. Does the air temperature differ by 1/1000th of a degree or 1/1000000000th of a degree? That minuscule, unmeasurable difference, the flap of a butterfly's wing in Beijing, may be the precise factor determining a hurricane in Texas a month later. Chaos theory didn't necessarily disprove determinism, but it crippled the demon's ability to function in practice. It showed us that even if the cosmos is a perfect clock, it is so sensitive that the mere act of knowing the time is impossible. But the truly fundamental attack on the demon's dominion arrived from the deepest strata of existence, the realm of quantum physics. Here, at the subatomic level, the universe ceases to be merely complicated and becomes fundamentally uncertain. Where classical physics demanded certainty, quantum mechanics only offers probabilities. Heisenberg's uncertainty principle shattered the notion that we can fully describe the state of any single particle. We cannot simultaneously know both the precise momentum and the precise position of an electron. The mere act of observation forces the quantum system to choose one reality, collapsing a cloud of possibilities into a single, definite state. This is not a matter of poor instruments or missing data. It is a feature of reality itself. The universe, at its bedrock, is genuinely indeterminate. The laws of nature do not dictate what will happen. They define the odds of what might happen. If the cosmos is built upon genuine chance, if the motion of an electron is truly random until the moment of measurement, then the premise of the demon is defunct. There is no original list of fixed coordinates from which to calculate everything else. The future is not already written in the atomic arrangements of the present. It is still being assembled, moment by probabilistic moment. Laplace's demon sought certainty and order, but the deeper we look, the more we find ourselves floating on an ocean of chance. The cosmos is not a perfectly sealed blueprint, but a negotiation between powerful, deterministic macro laws and a swirling, unpredictable micro world. The true architecture of existence, we find, is one defined not by flawless gears, but by possibility, uncertainty, and the persistent, irreducible reality of pure cosmic chance. It is in that irreducible uncertainty that we finally find the space for true novelty, true surprise, and perhaps the foundation of our own freedom. Quantum indeterminacy, the The universe's genuine randomness. We live most of our lives assured by the solidity of cause and effect. If we strike a match, it ignites. If we drop a stone, it falls. This is the architecture of the Newtonian world, a cosmos that runs like a magnificent, complicated clock. For centuries, this predictability was the highest compliment we could pay to nature. But the deeper we probe the mechanics of reality, the more that perfect clockwork facade begins to crack. The classical dream of complete determinism, the certainty that every future moment is merely the inevitable, calculable consequence of the present, shatters completely in the face of quantum indeterminacy. This is not a matter of poor measurement or insufficient data. This is not the fog of our ignorance. It is perhaps the most profound insight of modern physics. True randomness is woven into the fabric of existence. Before an observation takes place, a quantum entity, an electron, a photon, does not hold a single fixed identity. It exists only as a superposition, a cloud of mathematical potentiality, simultaneously possessing every possible state. It is everywhere and nowhere until the act of observation forces that cloud to collapse. And when that wave function collapses, the outcome is genuinely random. The electron is found at position A or B or C, and no amount of knowledge about its past could have predicted which specific location it would choose in that instant. The laws of quantum mechanics are rigorous, but they describe probabilities, not certainties. They give us the odds, but they never force the dice to land on a particular number. This distinction is critical. Deterministic systems can appear random if the initial conditions are unknown or too complex to calculate. This is pseudo-randomness. Quantum indeterminacy is acausal. Nothing caused that particular event to happen. It was a genuine roll of the cosmic dice, an instance of sheer chance injected directly into the heart of reality. If randomness truly underlies existence, then the entire philosophical debate concerning free will and fate takes on a devastating new dimension. For 2,000 years, the question was whether our choices were merely complex, pre-programmed outcomes. If the universe is a machine, where is the space for freedom? But if the machine itself incorporates genuine, uncaused events, if the future remains genuinely undetermined, even down to the level of the smallest particle, then the universe itself is perpetually writing its own script. The future is not just unread, it is unwritten. Every quantum leap, every act of radioactive decay, every interaction between fundamental fields injects an element of spontaneous newness into the cosmos. The universe does not follow a fixed trajectory set at the moment of the Big Bang. It is perpetually negotiating its path forward, utilizing the language of chance. This reality, however, does not descend into chaos. The magnificent hidden architectures of existence emerge from this fundamental uncertainty. While the behavior of a single particle is indeterminate, the statistical behavior of a trillion particles is immensely reliable. Randomness at the micro level gives way to predictability at the macro level. It is precisely because the quantum laws describe precise probabilities that we can trust the results, that we can design machines, build bridges, and predict the lifespan of the sun. The statistical averages are ironclad. We exist, therefore, in a duality, a vast, predictable ocean of classical reality resting upon an infinitely churning sea of quantum chance. The order we perceive is not the product of a preset chain of causes stretching back forever, but the stable structure that rises, statistically, from perpetual possibility. The universe is not a perfectly tuned instrument playing a fixed score. It is an improvisational orchestra. The laws of physics provide the instruments and the sheet music defining the structure, but the precise notes, moment to moment, are left to the spontaneous, genuine randomness of existence itself. This fundamental uncertainty is not a limitation on our knowledge. It is the signature of a universe that is alive, creative, and perpetually in the act of becoming. It is the space where potential resides, and perhaps the only meaningful stage for our own freedom. We are participants in a universe that allows for genuine surprise. We live not in the predictable certainty of a machine, but within the boundless canvas of thought. Leave your like. Of choice. Psychological arguments against free will. We have explored the internal constraints, the biology, the memory, the algorithms of the self. But what if the limitations imposed upon our choice are not merely internal? What if they are woven into the very fabric of space-time? Determinism is the ancient, cold premise that every event, including every thought, every decision, is the inevitable and necessary consequence of prior states. The universe, under this premise, is a vast, intricate clockwork mechanism set in motion eons ago. Every single turn of every gear today was irrevocably decided by the initial winding. If this is true, then the future is not a realm of boundless possibility. It is a single script already written, waiting only to be performed. Philosophers call this the inescapable causal chain. Our choices feel immediate, they feel spontaneous, yet they are merely the complex nodal points where history converges, where cause becomes effect. The 18th century mathematician Pierre-Simon Laplace formalized this chilling concept. He proposed that if an intellect, which we now refer to as Laplace's demon, knew the precise location and the momentum of every single particle in the cosmos at a single moment, it could flawlessly calculate the entire future and the entire past. There would be no secret left, no deviation possible. The future would be as fixed and unyielding as the past we remember. The great seismic challenge to this classical determinism arrived with 20th century physics. Quantum mechanics introduced uncertainty at the most fundamental level. Matter, it turns out, is not entirely predictable. Particles seem to exist in probabilities, only collapsing into definite states when they are observed. This raised a profound and existential question. If the universe is fundamentally governed by intrinsic chance, does that create space for human free will? Many argue that quantum randomness is the only possible escape hatch from the iron cage of determinism. But let us examine that possibility closely. If our decisions are not determined by our established character, our history, or our carefully weighed reasons, but are instead the random result of truly stochastic quantum jitters in the firing synapses of the brain, is that freedom? The answer logically is no. A choice made randomly is not a choice made freely. It is merely a choice made unpredictably. It certainly eliminates determinism, but it replaces it with caprice, with chaos. We trade the tyrannical rule of absolute cause and effect for the anarchy of the coin toss. In neither scenario does the I, the conscious reasoning self, exercise true control. Whether the universe is fundamentally deterministic or purely stochastic, the concept of autonomous agency remains perpetually trapped. We are left looking for a hidden architecture, a cosmic blueprint guiding existence. Perhaps that architecture is deterministic, a grand, elegant, and inescapable design where everything is necessary. Or perhaps it is merely probabilistic, a constant negotiation between possibility and realization, governed by odds we cannot influence, only ride. The deepest, most humbling insight of this perspective is that the universe doesn't care about our conscious veto. It proceeds according to its own laws, indifferent to our illusion of authorship. We stand here believing we are the authors of our actions, yet every single action traces its origin back to initial conditions we did not create, to desires we did not choose, and to natural laws we simply cannot break. The canvas of thought is prepared for us long before the paint ever touches the brush. We are simply the medium through which the deterministic or chaotic forces of existence express themselves. We mistake the execution of a universal program for the initiation of a personal act. The curtain falls, not on a decision freely made, but on the inevitable consequence of all that has ever been. Compatibilism, finding freedom within necessity. We left off at the precipice of determinism, staring into the cosmic clockwork, paralyzed by the notion that every thought, every movement was merely the inevitable consequence of what came before. That picture of reality seems to obliterate agency, reducing us to sophisticated dominoes falling in perfect sequence. But what if that terror is misplaced? What if the conflict between necessity and freedom is a false antagonism, a philosophical mirage. This is the core claim of compatibilism, that freedom does not require the supernatural breaking of natural laws, but rather a specific recognizable arrangement of those laws. The compatibilist argument begins by fundamentally redefining freedom. We often confuse freedom with randomness, with the possibility of acting uncaused. But in practical terms, in the court of law, in our everyday interactions, when do we say someone is not free? Not when they are caused to act, but when they are constrained to act. A prisoner is not free. A person forced at gunpoint is not free. A mind gripped by severe mental illness may not be fully free. The key distinction is constraint, coercion, compulsion. These are the true enemies of liberty. The philosopher David Hume argued that freedom is simply a power of acting or not acting according to the determinations of the will. If my action flows unimpeded from my intention, I am free, regardless of what caused that intention. If I choose to drink the water because I am thirsty, the thirst is a cause, the choice is determined, yet the act is perfectly free because it originated within my conscious self. But this simple view, acting on desire, can feel shallow. What if I am addicted? The action flows from my desire, yet we feel a profound loss of freedom. This leads to the deeper compatibilist architecture, notably championed by Harry Frankfurt. Frankfurt introduced the concept of the two-tiered self. We have first-order desires, the basic urges, to eat, to smoke, to procrastinate. And then we have second-order desires, the desires about our desires. The wish to not want to smoke, the wish to be a person who wakes up early. Freedom, in this richer sense, is the alignment of the action with the second-order desire. It is the ability to shape the architecture of the self, to act according to the will that we will to have. This is reflective self-evaluation, the ability to endorse or reject our underlying motivations. When our actions are rooted deeply enough in our authentic, reflectively endorsed self, then the action is truly ours. The underlying physical laws are still necessary, still running the code, but we become the proximate programmers defining the sequence. We are not external to the causal chain. We are the complex junction points where those chains intersect, where they are refined, and where they manifest as conscious intention. If the action originated from the deepest strata of my character, a fully constructed complex self, then that self is morally responsible. The causes led to me, and I am the necessary originating cause of the event. The structure of determinism ensures that accountability can be firmly fixed upon the individual, because the action flowed intelligibly from who they are. To reject this is to ask for a freedom that is random, unintelligible, and ultimately meaningless. We find ourselves then in a subtle, beautiful synthesis. The universe is a house constructed of necessary brick and mortar, but within those walls we are granted the blueprints to arrange the furniture, to choose the light, and to determine the purpose of the space. Necessity is the frame, freedom is the design. We are not exempt from the architecture of existence, but we are the architects of our own lives, finding agency not in fighting the current, but in choosing the precise angle of the sail. The freedom we seek is not found in a vacuum of causality, but in the profound, determined, and deeply owned choices of a conscious mind. We are free because we are definitively ourselves. The butterfly effect, deterministic chaos and sensitivity. The slightest movement, a breath held in the tropic air. We speak of the butterfly effect as a metaphor, a poetic warning that small things matter. But the concept is far more severe, far more fundamental. It is the physics of fate. For centuries, the ultimate dream of science was total predictability. The French mathematician Pierre-Simon Laplace imagined a demon, an intellect vast enough to know the position and momentum of every single atom in the universe. To this demon, the future and the past would be laid bare, transparent, a perfect, closed clockwork. This was determinism absolute, a universe without surprise. Everything that is, everything that will be, is simply the necessary unfolding of an initial equation. But this perfect clockwork, as we discovered, had a profound intrinsic sensitivity. In the early 1960s, a meteorologist named Edward Lorenz was running atmospheric simulations. He was searching for the rules of weather, trying to pin down the very breath of the planet. One day, he reran a sequence, but instead of using the full decimal output, say 0.506127, he truncated the input to 0.506. An infinitesimal rounding error, a difference far smaller than a single grain of sand. He expected the new simulation to diverge slightly, perhaps a negligible difference in the 100th hour. Instead, the resulting weather patterns rapidly spiraled into two wildly different realities. Within simulated weeks, the weather maps bore no resemblance to each other at all. The entire forecast had been shattered by a numerical tremor of 3 decimal places. This was the true butterfly effect, not just that small inputs lead to big outputs, but that systems governed by fixed, absolute rules can still become utterly unknowable. Lorenz had stumbled upon the architecture of deterministic chaos. The system is deterministic. There is no randomness injected, but its extreme sensitivity to initial conditions renders long-term prediction impossible. The mathematics remain rigid, but the outcome becomes fluid, elusive. We are not looking at true chance. We are looking at complexity so dense it perfectly mimics chance. Imagine tracing the path of that theoretical butterfly wing flap through the atmosphere. It creates a tiny whirl, which influences a gust, which redirects a current, which shifts pressure systems thousands of miles away. It is not magic. It is simply a chain reaction of causality that is physically and mathematically untraceable beyond a finite window. Lorenz's mathematics revealed something even stranger. The phase space of chaotic systems does not explode outward randomly. Instead, it orbits a specific structure, a hidden geometry known as a strange attractor. The weather pattern is always pulled back into a certain finite region. It will never leave Earth's atmosphere, for example. But within that confined space, the specific path is infinitely complex, never repeating itself. It is predictability constrained by inscrutable pathfinding. The universe has a roadmap, but every street name is written in invisible ink. If the rotation of a simple wheel or the convection of water is inherently sensitive to the smallest thermal whisper, what does that say about human life? Sure. About the global economy, about the tides of history, every political decision, every technological breakthrough, every chance meeting is an event that occurs in a system operating on the razor's edge of instability. The life you are living right now, the career you pursued, the people you love, could have been irrevocably altered by a single, forgotten choice made years ago, perhaps even by a choice made by someone you never met. Did you turn left instead of right because a subatomic particle collision moments earlier changed the firing rate of a single neuron in your brain? The question is frightening because it strips us of the simple, satisfying narrative of direct cause and effect. It suggests our grandest designs are merely the macroscopic manifestation of microscopic tremors. We live in a world scripted by physics, yet experienced as profound, exhilarating freedom. The butterfly effect tells us that beneath the orderly facade of existence, causality is a labyrinth. We cannot know the future, not because it hasn't been written, but because the pen that writes it is too sensitive, too precise, and moves too quickly for any mind to follow. We are left only with the wonder of the unfolding, the deterministic chaos that breathes life into the world, transforming the rigid architecture of physics into the beautiful, unknowable canvas of thought. Theorem and the non-local architecture of reality. The universe, as we tend to imagine it, is a perfect clockwork mechanism, a colossal set of gears set in motion by a primal force, operating according to immutable laws. This is the heart of classical determinism, the idea that if we knew the precise position and momentum of every particle right now, we could calculate the entire past and the entire future. Free will in this schema is an elegant illusion. We are merely following a script written at the Big Bang. For centuries, this vision held sway. From Newton to Laplace, the belief was firm: reality is local. Influence travels at most at the speed of light. Nothing that happens on Earth can instantly affect Mars. No spooky action at a distance. Causality is king, and its decrees are strictly enforced across space and time. Then came the quantum revolution, and with it, a peculiar, deeply unsettling whisper. Maybe reality isn't just local. Maybe there are hidden connections, profound architectures we've failed to see. Einstein himself, perhaps the greatest architect of modern physics, found this idea intolerable. He famously derided the inherent randomness of quantum mechanics, the element of pure chance, by stating that God does not play dice with the universe. He and his collaborators, Podolsky and Rosen, sought to expose what they saw as the incompleteness of quantum theory. They proposed a thought experiment, the EPR paradox, suggesting that the theory must rely on hidden variables, local instructions, preset conditions that dictate the outcome of any measurement, thereby restoring determinism in locality. The core of the paradox lay in entanglement. Imagine two particles, born together, spinning in opposite directions. We send one to the Andromeda galaxy and keep the other here. Quantum mechanics insists that until we measure the spin of our particle, neither particle has a definite spin. They exist in a superposition of possibilities. But the moment we measure ours and find it spinning up, the particle in Andromeda instantly collapses into the down state, instantly, faster than light. For Einstein, this instantaneous correlation was proof that the outcomes must have been determined all along by those hidden variables, local instructions written on the particles at the moment they separated. The measurement here didn't cause the collapse there. It merely revealed the instruction that was always there. This preserved locality. Decades later, a brilliant, unassuming Irish physicist named John Bell translated this profound philosophical debate into mathematics. Bell asked, if Einstein is right, and there are local hidden variables dictating the outcomes, what mathematical limits must the correlations between the measurements obey? He derived what is now known as Bell's inequality. This inequality acts as a clear line in the sand. If the universe is local, if it respects Einstein's demand that information only travels at the speed of light, dictated by local hidden variables, then experimental correlations between entangled particles must fall below a certain numerical threshold. But if the universe is non-local, if the instant, spooky action at a distance predicted by pure quantum mechanics is true, and there are no local hidden variables, then the correlations will violate Bell's inequality. They will be stronger than locality allows. This was no longer a thought experiment. Bell's work transformed the debate from metaphysics into physics, offering a concrete experimental test. In the decades that followed, experimentalists, most famously Alain Aspect, performed the required tests. They set up sophisticated apparatus, measuring entangled photons separated by vast distances, constantly changing the angles of the detectors to rule out pre-programmed instructions. The results were unequivocal. Time and time again, the measured correlations between the entangled particles violated Bell's inequality, significantly, robustly. This experimental evidence leaves us with a stark choice. Either locality is dead, and the non-local connections predicted by quantum mechanics are real, a reality where something measured here instantaneously influences something measured light years away, or determinism is dead, and the universe truly does involve fundamental chance, fundamentally irreducible randomness, meaning there are no hidden variables at all, local or otherwise, guiding the dice roll. What Bell's theorem ultimately proves is that you cannot have both. You cannot have locality and determinism. If you insist on a deterministic universe where outcomes are predetermined, then the hidden variables must be non-local, instantly coordinating across cosmic distances. If you insist on locality, where influence respects the speed of light, then the outcomes must be truly random, born of pure chance. The universe, it seems, is structured in a way that is profoundly interconnected, a single vast organism operating outside the confines of our classical expectations. The canvas of thought demands we confront a deep and unsettling truth. Beneath the appearance of solid local reality lies an architecture of non-local relationships, woven from the fabric of instantaneous universal communication. And in that architecture, the clockwork precision of determinism finds its ultimate challenge. Cosmic spaghetti: how initial conditions dictate universal fate. The universe began not as a blank slate, but as an impossibly dense, single point. Everything that has ever been, everything that will ever be, was already encoded within that initial moment, the cosmic seed. Imagine a plate piled high with impossibly intertwined, endless strands of spaghetti. That is the universe. Each noodle represents a timeline, a trajectory, a universal history. This is the cosmic spaghetti. The way those strands were laid down at the very start dictates every knot, every loop, every destination. We often speak of chance, of random events, yet every physicist knows the terrifying power of initial conditions. A slight nudge here, a minute difference there, and the resulting architecture of reality diverges utterly. This is the realm of chaos theory, the principle we lazily label the butterfly effect. It's not about magic, it's about sensitivity. In a perfectly deterministic system, if you could know the precise momentum and position of every particle in the universe right now, you would know the entirety of the future and the past. The issue isn't randomness. The issue is that our knowledge is inherently imperfect, and that imperfection, amplified over cosmic timescales, quickly renders prediction impossible. The system is deterministic, but functionally unknowable to us. We are forced to confront the staggering notion that the present state of the universe is merely the echo of its first breath. Every collision of galaxies, every whispered thought, is merely the consequence of an inertia set in motion long before light existed. The complexity we perceive as spontaneity is simply the inevitable playing out of a colossal, non-linear equation. The only true sanctuary for randomness, the only place where the cosmic spaghetti might genuinely fray, is at the quantum scale. Wave functions collapsing, particles tunneling, choices made by nature that appear inherently probabilistic. This is the bedrock of uncertainty. But even here, a profound question persists. Is that randomness truly free of cause, or is it merely the manifestation of variables so deep, so hidden within the initial universal constants, that they are simply beyond our resolution? Does the universe play dice, or is it simply that we, the observers, have blind spots too vast to map the loaded roll? If the initial conditions included the exact probability distribution functions for all future quantum events, then even quantum randomness is predetermined, simply expressed through an elegant probabilistic equation. The universe in this light is not an unfolding drama. It is a film already shot, and we are simply watching it run. The architecture is fixed. The hidden design dictated the speed of light, the strength of gravity, the existence of carbon. These parameters, these foundational choices made in the instant zero, define the menu of possibilities available to every star, every planet, every living mind. We are living within the constraints of an inevitable script, a beautiful, sprawling epic where every major plot point, the birth of the first galaxy, the death of the last star, was guaranteed the moment the spaghetti was laid out. The universe doesn't choose its path. It simply reveals the structure that was always waiting. Every layer of complexity we uncover, biological evolution, social constructs, technological leaps, is just the necessary consequence of the laws established in the inflationary epoch. If our actions, our loves, our mistakes, if every flick of the noodle was set in motion 13.8 billion years ago, what then remains of our agency? Perhaps the profound meaning of existence is not in the freedom of the path, but in the experience of walking it. We are the consciousness through which the universe observes its own fixed architecture. The beauty of the flower is not diminished because its growth was inevitable. The passion of a sudden decision loses none of its heat because the firing of that specific synapse was predictable given the initial electric charge. We are not free to change the cosmic outcome, but we are free to experience intensely and fully the miraculous unfolding of the predetermined fate. And perhaps that experience, that awareness of the inevitable and the beautiful, is the true purpose of the cosmic spaghetti. Variables, the search for subquantum mechanics. We live on a foundation built of certainty. Gravity holds us firm, planetary orbits are predictable for millennia, and the physics governing our daily lives describes a steady, reliable, clockwork universe. But the deeper we look, the softer the ground becomes. Below the certainty of classical mechanics lies the restless domain of the quantum world, a place where probability is not a failure of calculation, but the intrinsic mechanism of existence itself. The fundamental unit of reality, the atom, appears governed by irreducible chance. For the modern physicist, this raises the deepest possible question. Is quantum randomness genuine? Is the universe built on an essential flip of the coin? Or is this observed randomness merely the veil obscuring a deeper, more rigorous truth? This philosophical and scientific clash defined the very birth of quantum mechanics. Niels Bohr championed the standard view, accepting chance as fundamental. Albert Einstein could not. For Einstein, the universe had to be elegant, complete, and fully deterministic. His famous enduring protest was simple: God does not play dice. If quantum mechanics appeared incomplete, it must be because we were missing crucial information, variables hidden from our current observation. These hypothetical hidden variables would describe the true deterministic state of the particle, making the observed quantum randomness merely a statistical average of unknown complexity, much like the average behavior of gas molecules. For decades, this remained a profound, yet untestable debate, a clash of philosophical titans without a clear laboratory measure. Then came the profound mathematical insight of John Bell in 1964. Bell did not try to find the hidden variables, he found a way to exclude them, provided they obeyed the rule that classical physics holds most dear: locality. Locality requires that an influence or interaction cannot travel faster than the speed of light. Bell's work established a mathematical boundary, the Bell inequality. It offered experimentalists a clear black and white choice. If the inequality held, then the universe was governed by local realism, meaning Einstein's deterministic hidden variable dream was mathematically sound. If the inequality was violated, then the standard counterintuitive quantum mechanics, non-local and inherently strange, must be correct. The proving ground was entanglement. Take two particles inextricably linked, born from the same quantum moment. Measure the spin of one. Instantaneously, you know the spin of the other, no matter the distance separating them, be it a few feet or across vast gulfs of space. Bell's theorem proved that if reality were truly local, if influence could not travel faster than light, the statistical correlations of these entangled pairs would be capped at a specific value. Beginning with Clauser and definitively established in a series of increasingly sophisticated experiments by Alain Aspect and Anton Zeilinger, the results were devastating to local realism. The correlations observed in the experiments repeatedly and definitively exceeded Bell's limit. The conclusion was inescapable. The deep structure of the cosmos is connected in ways that defy classical space and time. We eliminated the simplest, most intuitive hidden variable theories, those that demanded the universe adhere to locality. Yet, the philosophical search for determinism continues down stranger pathways. If we wish to cling to the idea that the cosmic ledger is already written, we must explore options beyond local realism. We are left, for instance, with the staggering fatalism of superdeterminism. This hypothesis suggests that the universe is so tightly deterministic that even the choices made by the experimenter, which variables to measure and when, were predetermined from the very first moment of the Big Bang. It is an architecture of existence that eliminates chance entirely, but demands that the entire future of the universe is locked into place. Or perhaps the path lies with the de Broglie-Bohm theory, a non-local hidden variable interpretation where the particles are guided deterministically by an underlying field, a hidden pilot wave that instantly links every corner of creation. The pursuit of subquantum mechanics is the deepest human attempt to reconcile freedom and necessity. Do we live in a universe governed by genuine, irreducible chance where events simply happen for no reason? Or is the entire story of the cosmos guided by hidden parameters that reveal a universe utterly, chillingly determined? The hidden architectures of existence remain elusive. We stand at the threshold of the quantum basement, forever searching for the cosmic blueprint, trying to decide if we are merely players in a grand, pre-scripted drama, or if somehow we still hold the dice ourselves. This is the central argument of modern cosmology, the final word on free will versus fate, written in the mysterious correlations of light and shadow. Epistemology of chance. Is randomness merely ignorance? We speak of chance as if it were a fundamental force, a mischievous spirit governing the roll of the dice or the flip of a coin. But perhaps chance is not a law of nature. Perhaps it is merely the metric of our own sensory failure, the space where causality retreats beyond the perimeter of human calculation. For centuries, the philosophical consensus held that randomness was purely epistemological, a failure to know. If we knew the precise velocity and position of every gas molecule in the room, the scent diffusion would cease to be random. It would be a solved equation. Imagine the universe as an impossibly intricate machine. Every particle, every vibration, every flicker of light set into motion by an event preceding it. If we possessed infinite computational power, the mythical intelligence known as Laplace's demon, we would see the future unfold not as probability, but as pure, inevitable arithmetic. Every lottery drawing, every collision of traffic, every choice we deem free would simply be the dictated next line in the universe's grand script. The problem is not with the existence of cause and effect, but with the practical limitations of observation. In systems of sufficient complexity, a slight variation in the starting conditions, a butterfly wing beating in Beijing, can render future states wholly unpredictable. We call this chaos. But chaos is not the absence of order. It is order so dense, so fractal, that it appears featureless to the limited observer. It is determinism in disguise, too intricate for the human mind to process in real time. We mistake the limits of our own instruments for an openness in the universe. We substitute the law of averages for the law of certainty, creating the illusion of chance to manage our inability to track every hidden variable. But then, the architecture of the very small presented us with a profound, almost defiant mystery. At the quantum level, many physicists argue that chance is ontological. It is not merely a gap in our knowledge, it is woven into the foundational fabric of existence itself. The decay of a radioactive atom, the precise moment a photon lands. These events appear, at least currently, to lack a hidden variable that determines their outcome. They are true chance events, residing outside the tyranny of classical causality. If this is true, if true, uncaused, irreducible randomness exists, then the universe is not the flawless clockwork imagined by the Enlightenment. It is a constantly self-generating narrative, injected with moments of pure novelty. The hidden architecture is not rigid, but fluid, allowing for spontaneous deviation. It means that even Laplace's demon, armed with omniscience, would hit certain cosmic breakpoints where the answer is truly indeterminate, a quantum roll of the die that resets the board. So, where does that leave us? Are we living in a fundamentally random universe, or one whose complexity merely exceeds our grasp? The truth may lie in the uncomfortable coexistence of both. We inhabit a macroscopic world governed primarily by statistical ignorance, where billions of microscopic deterministic events average out into predictable, comforting patterns, the Gaussian curve, the law of averages. But beneath that, in the shadows of the subatomic, perhaps there is a genuine wellspring of novelty, a necessary chaos that prevents existence from becoming a closed, predictable loop. The epistemology of chance, therefore, becomes the mirror reflecting our own position within the cosmic architecture. The closer we look at the ordinary world, the more deterministic the statistical structures appear. But the deeper we probe, the more mysterious, and ultimately, the more free the foundational layer becomes. The hidden architect may not be a rigid dictator setting the final blueprint, but an artist who reserves the right to improvise in the details. And our perceived randomness is merely the sound of that cosmic improvisation echoing through the cathedral of our own limited perception. Chance is the signal that we are observing a machine that is still writing its own code. Subscribe. Factuals, mapping the roads not taken. We are, fundamentally, creatures defined by paths. Every decision we make carves a single, forward trajectory through the wilderness of possibility, leaving behind an inescapable trail of ghosts, the roads not taken. This is the domain of the counterfactual. It is not merely idle speculation, but a rigorous, often painful, mapping of the world that almost was. It is the constant humming dissonance in the background of existence, prompting us to examine the terrifying fragility of the present moment. If one tiny variable had shifted, a delayed bus, a momentary glance, a single word left unsaid, would the entirety of our known reality splinter and reform into something unrecognizable? To truly appreciate the weight of the counterfactual, we must submit the inquiry to the harshest critic, the relentless logic of determinism. If the universe operates like a single, flawless clockwork mechanism set into motion at the instant of the Big Bang, then every subsequent event, every collision of particles, every chemical reaction, and every synapse firing in your brain was absolutely necessitated. The future is merely the execution of an ancient, fixed code. In this hard, deterministic model, the concept of the road not taken is a profound delusion. There are no actual alternatives, only the illusion of choice playing out against the fixed scaffolding of space-time. The counterfactual is nothing more than a momentary lapse in cosmic memory, a failure to remember the only script that was ever written. If the universe is deterministic, the other path didn't just fail to happen, it was impossible. But this fixed architecture, this ironclad inevitability, cracks when confronted with the deeply inscrutable nature of chance. Modern physics, particularly in the chaotic and bewildering depths of quantum theory, suggests that at the fundamental, foundational level, reality is not certain, but probabilistic. The precise moment of an atom's decay, the exact path a photon chooses to take, these phenomena are governed by statistical likelihoods, not immutable deterministic laws. Herein lies the true destabilizing power of the counterfactual. If genuine randomness, genuine indeterminacy exists at the very heart of existence, if the building blocks of reality possess an inherent infinitesimal wiggle room, then the past was not fixed, it was merely realized. Another path was genuinely available, lying just outside the light cone of our current reality. This conflict between deterministic inevitability and genuine chance defines the hidden architecture of existence. Is our reality a single, unbroken chain of cause and effect, where free will is merely a comforting neurological trick? Or are we, in every moment, riding the crest of a wave of collapsing probabilities, genuine agents in the ongoing creation of the universe? The magnitude of this question informs our obsession with the alternative. We map the roads not taken because we seek the exact boundary between necessity and freedom. We want to know where the script ends and where improvisation begins. The very process of engaging with a counterfactual scenario, imagining the consequences of a different choice, is an act of intellectual rebellion against fate. It is our human way of searching for the seams in the tapestry of time, testing the tensile strength of the reality we inhabit. We ask, what if, because we are searching for the precise moment where our own hand truly reached out, seized the thread of possibility, and pulled the future toward us? If we can prove that a different path could have been taken, we prove that we are not passive witnesses to fate, but active, indispensable participants in the unfolding drama of existence. The counterfactual, ultimately, is the ultimate existential diagnostic tool. It asks, could I have been the architect of my own life, or was I merely the material? And in that question, the whole drama of consciousness unfolds. Server problem: consciousness and the collapse of probability. The world we inhabit is a machine of certainty. Every thrown stone, every turning gear, every gravitational pull follows a relentless, predictable script. Cause leads to effect. Newtonian physics gave us the comfort of knowing that, given enough information, the future was merely an unfolding consequence of the past. It suggested an infinite domino chain, perfectly predetermined since the first instant of time. We were passengers on a trajectory that had already been charted. But then we peered into the smallest spaces, into the architecture of the atom, and the relentless script dissolved into smoke. Down there, at the quantum scale, the universe stops playing the game of certainty and begins playing the game of chance. This is the heart of the observer problem, a metaphysical trapdoor built into the foundations of reality. Before we look, an electron isn't a particle in a definite place, nor is it merely nowhere. It exists in a vast spectral haze, the superposition. It is simultaneously everywhere it could possibly be. It exists as a wave of potentiality, a smear of possibility defined by mathematics, not material fact. This is the famous wave function. It describes the comprehensive map of all things that might happen, a universe of countless parallel potentials, all humming together in the dark. The profound philosophical rupture occurs when we choose to measure it. The instant a conscious entity intervenes, whether a scientist with an instrument or perhaps even just an unwitting perception, the wave function collapses. The infinite potentials instantly resolve into a single concrete reality. The electron chooses its location. The potential becomes the actual. The question that has haunted physics and philosophy for a century is, why? What is it about observation that forces reality's hand? Some argue the collapse is purely mechanical, the result of the apparatus itself interacting with the delicate quantum state. But many of the founding thinkers of quantum mechanics, including giants like Bohr and Wigner, suggested something far more disturbing: that consciousness, the internal experience of observation, is the essential element. If consciousness causes the collapse, then our minds are not merely biological afterthoughts, the incidental byproduct of complex chemistry. They are, instead, active participants in reality construction. We are not simply watching the film, we are pulling the switch that selects which film gets screened. If this premise holds, then the classical determinism of the clockwork universe is fundamentally broken. Free will is not an illusion tolerated by physics, but an engine essential for physics to operate. Our conscious choices, the very act of focusing attention, constantly prune the infinite tree of possibility into the single path we call now. But if we are the sculptors, what determines the final outcome of that collapse? If the universe is built on chance, then the choice made at the moment of observation is random, pure mathematical caprice. Yet, if the choices are truly random, where is the order we perceive? Where is the coherence of our shared experience? This brings us back to the hidden architectures of existence. If the system is not random, if the collapse follows a deeper, non-local logic, then perhaps the observer is not us at all. Perhaps the individual mind is merely a localized node in a greater universal consciousness, a cosmic architect that imposes order onto the infinite chaos. This ultimate observer doesn't merely watch, it dictates. It acts as the anchor point, ensuring that even within a sea of infinite quantum possibilities, the narrative of existence maintains its structure. It ensures the collapse results in a reality capable of supporting the laws of physics and, crucially, capable of producing observers who can then ask these questions. The observer problem forces us to confront the terrifying possibility that existence is not fixed but fluid, waiting for the cognitive moment of validation. We live on the razor edge between all things possible and the single thing that is. And our minds, the fleeting, fragile products of matter, might hold the key to the entire machinery. We are the architects of the moment, collapsing the grand tapestry of potential into the threadbare certainty of the present. We are the chance that makes the deterministic world possible. Predictive coding and the architecture of the brain. We often imagine the universe as a vast, echoing chamber where events unfold sequentially, cause leading simply to effect. A chain. We imagine the human mind as a mirror reflecting that chain, passively receiving the light and shadow of the present moment. But that image is a romantic lie. The universe and the brain that attempts to comprehend it is not built on reaction. It is built on prediction. It is a tireless, terrifying machine of anticipation. This is the core tenet of predictive coding, the understanding that we do not wait for the signal to arrive before we decide what it is. We start with a sophisticated guess. We start with expectation. Imagine the world inside your skull. It is dark, the data streaming in, light, sound, texture is noisy, ambiguous, incomplete. To make sense of this chaos, the brain must constantly construct a high-resolution internal model of reality. It sends a top-down signal, a highly detailed forecast of what should be happening right now. That forecast, the prior, is everything. When the actual sensory input arrives, the bottom-up signal, the brain doesn't just register it. It compares it. It measures the difference between what it expected and what it received. That difference, that moment of discord, is the prediction error. The entire architecture of the mind is dedicated to minimizing this error. We are not designed to be surprised. We are designed to be correct. Our reality, therefore, is not a raw stream of data. Our experience of the present moment is the brain's updated forecast, slightly modified and smoothed out to account for the incoming discrepancy. We live in a carefully controlled hallucination, a consensus reality created by constantly suppressing the unexpected. What does this profound mechanism imply for the grand themes of existence? If every decision, every movement, every conscious flicker of thought is merely the output of an exquisitely tuned algorithm striving to maintain internal consistency, where does the self reside? We are the culmination of past prediction errors, solidified into stable priors. We are functionally trapped within the perfection of our own predictive model. This introduces the deep chill of determinism. If the future is merely the most optimized outcome of minimizing prediction error based on the infinite input of the past, then the path forward is already drawn. We are sophisticated, conscious clockwork, meticulously predicting our next tick. Our freedom becomes reduced to the illusion of choice within a perfectly self-regulating system. We become aware that the hidden architecture of the mind is fundamentally deterministic. We look for patterns. We demand sequence. We are profoundly uncomfortable with noise because noise represents the failure of our prediction engine. We find comfort in the expected rhythm of things, the sun rising, gravity working, memory retrieving. Yet, existence itself remains tethered to chance. True chance, pure randomness, the unpredictable quantum flutter at the edges of the macro system, is the only thing that can truly generate a massive prediction error, a fault line in the architecture. It is the unguessable variable. The human condition, then, is this beautiful, tragic tension, the relentless evolutionary pressure toward absolute predictability, clashing against the inescapable, magnificent chaos of the world outside. We are the prophet designed to see the future clearly, struggling to interpret the rare, blinding flash of the truly novel event. We build our world out of expectation, and the only genuine breakthroughs, the only true innovations in science or art, come from the sudden, jarring recognition that our forecast was wrong. This is the hidden architecture of existence, a deep, quiet yearning for order, constantly being tested by a universe that fundamentally refuses to comply. We are the instruments of that yearning, measuring the silence, waiting for the one unexpected sound. The mind, the ultimate predictor, locked in an eternal negotiation with fate. Full of entropy, the universal trend towards disorder. Every story ever told, every galaxy ever born, adheres to a single, relentless mathematical imperative. It is the law that defines the boundaries of the possible and dictates the inevitable final scene. We often look for divine intervention or pure chance to explain the chaos of the world, But the deepest current flowing through the cosmos is far more elegant and far more terrifyingly predictable. This current is known simply as entropy. It is the quantification of disorder, the universal tax levied on energy. The second law of thermodynamics is arguably the most powerful constraint in the universe. The total entropy of an isolated system can never decrease. Things fall apart. Heat always flows from hot to cold. Energy spreads out, dilutes, and becomes less useful. Order demands constant energy expenditure. Disorder requires nothing but time. It is the path of least resistance, the easiest, most probable arrangement available to reality. Why is the past fundamentally different from the future? Why can't we unbreak the glass or unmix the cream from the coffee? Because every physical process generates waste energy, radiating out into the system, increasing the overall level of disorganization. Entropy is the universe's indelible arrow of time. It points relentlessly toward homogeneity, a state where all temperatures are equal, all energy is evenly distributed, and nothing interesting can ever happen again. And yet, look around, we exist. We are complex, highly ordered systems, cities, biospheres, neural networks, fighting this universal trend. A star is a furious engine of order, fusing simple elements into heavier ones, battling gravity's pull. How can islands of complexity emerge in a sea designed for simplicity? The answer lies in the critical distinction between the local and the total. A living cell, or a star, reduces its own internal entropy, achieving a temporary, astonishing level of order. But it does so by exporting an even greater amount of entropy into its surroundings. We survive by increasing the chaos outside of us. We are magnificent, fleeting, localized rebellions against the inevitable decay, temporary pockets of structure fueled by the accelerating breakdown of everything else. This interplay defines the hidden architecture of existence. If the ultimate destination, maximum entropy, the heat death of the universe, is predetermined, how does that affect the choices we make, the paths we take in the middle? Is the universe strictly deterministic, following perfect physical equations, or is the inherent randomness of microscopic interactions, the unpredictable jitter of the particle, the true engine of change? Quantum physics whispers of pure chance, of probabilities rather than certainties. But thermodynamics, driven by entropy, shouts a crushing certainty. The destination is fixed. The system must dissolve. Determinism dictates the endpoint. Chance dictates the specific, sprawling, beautiful route we take to get there. Entropy is the hidden architect, ensuring that while the path may appear freeform, the blueprint of the final structure is already sealed. It is the law that guarantees the universe plays the long game, even if the individual steps are purely random. We are therefore transient sparks of purpose in a vast mechanism designed for purposelessness. We generate art, systems, and meaning in the finite period before equilibrium reigns supreme. Perhaps the true essence of consciousness is not to achieve eternal order, which is impossible, but simply to observe and appreciate the spectacular, improbable struggle against the current. Entropy guarantees that every structure, every memory, every thought is fundamentally temporary. It provides the ultimate context for ambition, love, and creativity. We are granted a brief, energetic window of disequilibrium. And within that window, framed by the certainty of universal decay, we find our freedom to create the complex, beautiful, and momentary patterns we call life. The universe is running down. Yes, but in the friction and the noise of that decline, the greatest works of order are briefly written, and then we return to the quiet, final parity. Fractals and self-similarity, the structures of randomness. We are trained to look for straight lines, smooth curves, and perfect circles. We trust the geometry of Euclid, built on the foundations of the stable and the ideal. When we encounter complexity, the jagged cliff face, the branching tree, the shifting patterns of a storm, we categorize it as randomness, the antithesis of order. But what if randomness is simply order viewed from the wrong distance? The mathematics of the world often rejects the smooth and embraces the broken. This is the domain of the fractal, the mathematics of the ugly, the structure of chaos itself. Benoit Mandelbrot gave it a name, but the phenomenon has always been the universe's most efficient secret. Consider the coastline. The famous question is, how long is the coast of Britain? The answer depends entirely on your ruler. Measure it with a 50-mile yardstick, and you get one length. Measure it with a 1-mile yardstick, accounting for bays and inlets, and the length increases dramatically. If you could measure every grain of sand, the length would approach infinity. This is the fractal signature, self-similarity across scale. Zoom in, and new complexity emerges, identical in character to the whole. The pattern replicates itself eternally, a mirror facing a mirror, creating infinite length within a finite space. Look around. The universe favors this jagged efficiency. The structure of a tree, optimized for absorbing sunlight, is a fractal. The pathways within your lungs, optimized for maximum surface area, are fractals. The electrical discharge of a bolt of lightning, the distribution of matter in the vast cosmos, all adhere to this strange recursive rule. The architecture of a small fern leaf uses the same blueprint as the immense river delta flowing into the ocean. It is a cosmic copy machine capable of generating infinite variety and complexity from one master key. This is where the mathematical touches the philosophical. Fractals are not born from genuine randomness. They are born from deterministic iteration. They are the result of a single, simple formula repeated endlessly. A tiny initial difference in that calculation, a minuscule shift in the starting conditions, is magnified exponentially with every repetition. We call this the butterfly effect, the cornerstone of chaos theory. The rule remains absolute, yet the output is so sensitive, so unique that we label it chaos. We perceive chance because we cannot calculate the billion iterative steps that preceded the event. But the event was not chance, it was necessity driven by iteration. If the structures of nature are governed by these self-similar architectures, what does that say about our concepts of determinism and free will? Is the universe merely running a massive, beautifully complex algorithm? The fractal suggests that true randomness is an illusion, a category invented to describe complexity we haven't yet had the capacity to decipher. We struggle to understand the unpredictable path of a hurricane, but the hurricane is merely following simple atmospheric rules iterated over a vast scale. There is an architect, but one who builds not with rigid, predictable plans, but with recursive functions. The system is designed to surprise itself. We are ourselves systems within systems. Our family structures are self-similar to our societal structures, which are self-similar to the macroeconomic forces that shape our world. We are fractal creatures living in a fractal reality. The fractal is the universe's most powerful teaching tool, demonstrating that order and chaos are not opponents, but different views of the same deep structure. It reveals that the messiest reality is governed by the simplest, most elegant instruction of all: repeat. And in that endless repetition, we find the hidden architecture of existence. Emergence. How order arises from random noise. We look out at the universe, or perhaps just at a cloud of smoke dissolving into the atmosphere, and we see what appears to be pure noise, static, chaos, the relentless randomness that seems to govern everything from the decay of a particle to the formation of a galaxy. Yet somehow, from that vast, meaningless hiss, structures bloom. Order asserts itself. This is the ancient, almost philosophical puzzle of emergence. How does complexity arise from simplicity? How does pattern arise from randomness? And how does the consciousness, observing the cosmos, emerge from the carbon dust of the cosmos itself? We often confuse complexity with randomness. True, absolute noise is almost impossible to maintain. Introduce a boundary, introduce time, introduce energy gradients, and structures inevitably begin to form. Throw enough pebbles into a box, and they will naturally arrange themselves into the minimum energy configuration. They seek equilibrium, and that seeking is the first principle of order. The universe isn't a lottery, it is a high-stakes, multi-dimensional game of pool, where every collision, however complex or distant, is fundamentally governed by a finite set of rules. We perceive chance only because we lack the computational capacity to trace the causal chain of every single impact. The signal was never truly created from the noise. The signal was the inherent deterministic behavior of the system's simple operating constraints, waiting for the right conditions to reveal itself. Consider the phenomenon of self-organization. No central authority instructs a crowd of people to flow efficiently down a busy sidewalk, yet traffic manages itself. No single bird dictates the movements of the flock, yet thousands of starlings move as one terrifyingly fluid shadow against the twilight sky. Murmuration, flocking, swarming. These are demonstrations of local rules translating into global behavior. At a critical point, the moment a liquid is heated from below, forming perfect hexagonal convection cells known as Bénard cells, or the moment a simple algorithm forces an individual to only observe its immediate neighbors, order snaps into existence. The most profound examples often involve the fewest instructions. The mathematician John Horton Conway's famous game of life is played on a two-dimensional grid with only 3 or 4 simple rules for birth, survival, and death. Yet running that simple iteration long enough produces objects of stunning complexity, gliders that propagate across the grid, pulsars that oscillate in perfect rhythm, and patterns so sophisticated they can simulate computational logic. A vast, unpredictable universe built on a handful of constraints. This suggests that the stunning diversity of our reality, from economics to ecosystems, from the formation of crystalline structures to the structure of human language, is not the result of infinite instructions, but the inevitable consequence of a severely limited architectural blueprint. Where does this leave us in the debate between determinism and chance? If the vast complexity of human consciousness, our art, our morality, our very sense of self, is merely the emergent property of billions of neurons adhering to simple electrical and chemical rules, are we truly agents, or are we merely sophisticated dominoes in a beautiful, long-running chain reaction? The chaos we observe, the chance we invoke, is often just the name we give to hidden determinism. The universe is not random, it is merely massive. The architecture is not absent, it is simply concealed by its own scale. We are characters within a book that is already fully written. We only experience it word by word, chapter by chapter, mistaking the unfolding for invention. Emergence teaches us a profound humility. The highest forms of beauty, stability, and intelligence are simply the most stable patterns arising from the lowest level of physical interaction. Our search for a supernatural guiding hand is often misplaced. The architect is not outside the building pulling the strings. The architecture is the building. We are the noise, but we are also the necessary, inevitable music that the noise produces. And that order, that terrifying and beautiful necessity, is the true architecture of existence. Markov chains and memoryless systems. We are creatures of history. We track the trajectory of every choice, every consequence, logging millions of inputs to predict the next moment. Our consciousness is, fundamentally, an exhaustive database, calculating the future based on the total burden of the past. We assume this complexity is fundamental to existence. We believe that to truly know where something is going, you must know where it has been. But deep within the mathematics of change, there exists a profound, almost defiant simplification, a conceptual architecture that dismisses history entirely. This is the system defined by the Markov property. It is the definition of memorylessness. Imagine a machine that exists in a sequence of states. Its future state, the place it will move to next, is determined solely by its current location. All the steps taken to arrive at this specific juncture, the detours, the close calls, the miraculous recoveries, are erased the moment the system settles into the now. The past is irrelevant. It is perfectly compressed into the present. This is the central beauty and the subtle terror of the memoryless system. It is eternally clean slate, perpetually starting over, yet bound by the fixed probabilities of its next transition. Think of a game like chess. The valid moves available right now are critically dependent on the entire history of the game. The positions of every piece moved 20 turns ago. Chess is deeply historical, profoundly burdened. Now consider something far simpler: snakes and ladders. If you are on space 43, the only thing that matters is the roll of the die. It does not matter if you were just penalized from 99 or if you climbed a ladder from 5. The rules of probability apply to the number 43, and the only input is the roll you are about to make. The system is stateless except for the single state it currently occupies. We try to fit the grand, chaotic processes of the universe into this framework. We attempt to model the weather, the movement of prices, the very evolution of language, using Markov chains. We seek that elegant simplification, hoping to find the underlying matrix of transition probabilities, that cold, deterministic script dictating all the possibilities of chance. If we can define the rules of transition, the percentage chance of moving from state A to state B, then the system, despite appearing random, is actually revealing its hidden architecture. The sequence of moves is random, yes, driven by pure chance at every step, but the rules governing the percentage chance of those moves are fixed. This is where chance and determinism collide in a delicate, almost mystical balance. The chain offers endless paths, guaranteeing variation, guaranteeing surprise. Yet over vast spans of time, the system will always reveal its fundamental nature. It will settle into its steady-state distribution, where the probability of being in any given state ceases to change. The memoryless system doesn't escape fate, it simply bypasses the intermediate calculations. It shows us that destiny isn't necessarily a long, complex calculation stretching back to the Big Bang. Sometimes, destiny is contained entirely in the simple, immediate rule governing the next movement. In this architecture, the architecture of forgetting, we find a strange parallel to human existence. To live solely in the present, to let the past collapse completely into the current moment, is often the spiritual objective we chase. But unlike the pure mathematical abstraction, we can never truly forget. We are memoryful. We carry the weight of every prior step. The Markov chain remains the quiet counterpoint to our complexity, a reminder that the deepest truths about existence might not be found in the accumulation of detail, but in the ruthless elegance of starting fresh, asking only, where am I now, and what are the rules for my next step? It is the architecture of inevitable movement, governed by the cold certainty of probability, yet free from the shackles of history. It is the purest form of movement we have yet defined, the perfect dance between hidden determinism and visible, intoxicating chance. Thermodynamics of fate, time's irreversible arrow. We live in a world defined by directionality, not just north or south, up or down, but forward. Time is the most fundamental, the most unyielding dimension we inhabit, yet it is the only one we cannot traverse in reverse. But why? Why does the universe permit memory of the past but never foresight of the future? Why can we watch a vase shatter but never watch it assemble itself back into pristine order? The answer lies in the slow, inevitable march toward equilibrium, the concept physicists call entropy. It is the cosmic law that governs every process, from the nuclear decay within a dying star to the cooling of a cup of coffee on your desk. The second law of thermodynamics dictates that entropy, the total disorder in a closed system, must always increase. Irreversibility is the signature of our existence. Entropy is often simplified as disorder, but it is more accurately the measure of multiplicity, the sheer number of microstates available to a system. A highly ordered system has few options. A disordered one has billions. Nature statistically always opts for the state with the highest probability, the highest multiplicity. This means the future isn't necessarily mandated by some celestial blueprint, but it is statistically predetermined by the relentless expansion of available outcomes. If you flip a single coin, the result is random. If you flip a billion coins every second for an eternity, the average outcome is absolutely certain. The universe is defined by that statistical certainty, driving us toward a vast, cold heat-death average. The classical worldview, famously articulated by Pierre-Simon Laplace, asserted a powerful, chilling determinism. If an intellect, Laplace's demon, could know the precise position and momentum of every single particle in the cosmos at this instant, that intellect could theoretically calculate the entire future and the entire past. It suggests our lives are simply long, complicated trajectories like billiard balls knocking into one another according to ironclad Newtonian laws. Yet, this view immediately runs into the messy reality of chaos theory. The smallest initial perturbation, the infinitesimal gravitational tug of an unobserved particle, the subtle fluctuation in air pressure caused by a distant butterfly, can dramatically alter the eventual outcome of a macroscopic system, be it a thunderstorm or a political election. It is not that the system is non-deterministic, it is that the system is exquisitely sensitive, rendering true prediction practically impossible. The future is coded in the initial conditions, but those conditions are buried in an ocean of information we can never fully access. And so where does that leave our supposed agency? Are we merely complex thermodynamic machines grinding along the entropic path laid out for us? Perhaps the feeling of choice, the deep-seated belief in free will, is simply the conscious experience of navigating an architecture so vast, so interwoven, that its underlying determinism is invisible to the inhabitant. We experience the world locally, moment by moment, in a frame defined by limited information. The future feels open because the initial conditions were set so long ago in such an impossibly precise yet chaotic configuration that their echoes manifest as seemingly arbitrary chance. Maybe chance, then, is not the opposite of fate. Maybe it is simply the name we give to the level of complexity that transcends our current ability to calculate. The hidden architecture is not necessarily a grand designer pulling the strings, but the intricate, unyielding logic of physics itself. Time moves because of entropy. Entropy guarantees a statistical destination. We are bound by the irreversible arrow of existence, riding the wave of maximum probability, mistaking the inevitability of the path for the openness of the journey. The thermodynamics of fate ensures that the future, whatever it holds, will always move away from the past, never toward it. Existential risk and the architecture of system collapse. We look for the seams in the world, the hidden geometry that governs consequence. We call it history or physics or sometimes fate. But when we talk about systemic collapse, the true terminal dismantling of civilization, we are discussing architecture. Not of steel and glass, but of abstract ideas, interconnectedness, and failure tolerance. The fundamental tension driving this conversation is the ancient philosophical duel between determinism and chance. Is the great filter a guaranteed endpoint, woven into the fabric of complexity itself, or is it merely a statistical anomaly waiting to strike? Determinism suggests that the blueprint for our undoing was finalized the moment the system achieved a certain threshold of scale and integration. Consider the inherent flaws in any grand edifice, the stress fractures, the unavoidable material fatigue, the eventual yielding to gravity. The failure isn't if it cracks, but where the predetermined stress lines finally yield. We mistake duration for permanence. We build elaborate global houses of cards on principles that are inherently unsustainable, extracting beyond replenishment, optimizing efficiency until every scrap of redundancy is gone. This path toward exponential risk was not a choice, it was a calculation. The equation was solved before we finish writing the variables, and the solution always involves a zero state. The system is designed to fail because it is designed to grow indefinitely within a finite sphere. The collapse, viewed through this lens, is a mathematical certainty, the final payment due on an unpayable debt. Yet, we cannot discount the static, the noise in the signal. We cannot ignore the profound disruptive power of chance. The butterfly flapping its wings in the primordial jungle now becomes the sudden mutation of a novel contagion, the misfiring algorithm that coordinates global defense, or the singular, low-probability, high-impact event that cascades into catastrophe. These are the black swans that defy our extrapolation models. This is pure stochastic reality asserting its terrifying relevance. If the system is a vast, complex machine, determinism dictates the design of the gears, but chance throws the wrench. The collapse, if triggered by such an outlier, is not a gentle slope toward decay, but a sudden, violent phase transition. The question shifts entirely. Did we fail because we were structurally flawed, or simply because the universe finally dealt us an impossible hand? Perhaps the distinction is an illusion. The hidden architecture of existence is the stage upon which determinism and chance perform their terrible, fatal duet. Determinism dictates the fragility. Chance provides the trigger. A resilient system absorbs a massive shock, integrating the damage and finding a new equilibrium. A brittle system, one that has optimized away its margins, its buffer states, its capacity for internal error correction, collapses from a minor tremor. Our collective design flaw is not one specific policy or technological choice, but the eradication of systemic redundancy. We built a system so tightly integrated, so optimized for immediate efficiency, that local failure instantly becomes global cascade. We did not just build a structure, we built a singularity of risk. The inevitable factor was not the specific trigger event, the war, the virus, the climate tipping point, but the guaranteed exponential response to any trigger event. The existential risk, therefore, is not a simple consequence. It is the ultimate expression of this architectural failure. It is the final zero-sum ledger entry. We are left contemplating the cosmic joke. Did we possess true agency as we rushed toward this precipice, or were we merely the necessary conscious component tasked with executing the deterministic collapse? We are the thinkers who build the trap, and the prisoners who admire the ingenuity of the locks. To study the architecture of system collapse is to study the fundamental limits of our tenure in the universe. It is the realization that the grandest tragedy is the one that was pre-written, and we, the actors, were only ever playing our part in a magnificent, self-fulfilling prophecy, and when the final structural piece yields, the silence will not speak of chance, but of inevitability. The synthesis, fate, fortune, and the responsibility of being. We are haunted by the question of architecture. Is the world a grand, infinite machine, predictable down to the flutter of a moth's wing, or is it a tapestry woven equally by pattern and by pure, irreducible accident? For centuries, the Western mind gravitated toward the machine, the great clockwork universe wound tight at the moment of creation, where every interaction is simply the execution of a pre-written command. This is the seductive, comforting framework of determinism, the unbroken chain of necessity. In this vision, everything that is happening now is the inevitable, necessary output of the moment that preceded it. Our decisions are not choices, they are the observable effects of countless prior causes, genetic, historical, and chemical. Our perception of agency in this rigid framework is merely the frantic internal monologue of a mechanism already executing its preordained code. We feel like captains, charting a course across the open sea, but we are simply passengers, watching the inexorable current of necessity pull the rudder, convincing us that our hand holds the wheel. But the clockwork began to stutter. The deeper we looked into existence, past the Newtonian gears and into the quantum realm and the complexity of systems, the more chaotic the architecture revealed itself to be. Enter chance, fortune, the sheer, untamed accident that refuses to be quantified, predicted, or apologized for. Modern science, particularly chaos theory, suggests that existence is not just a smooth, predictable gradient of cause and effect, but a landscape peppered with irreducible uncertainty. The tremor of a butterfly's wing, the quantum noise in an electron's orbit, these minute variations, multiplied across the system, can rewrite the trajectory of a storm 1,000 miles away, or the arc of a human life. This unpredictable hum is the necessary counterpart to static fate. We must stop seeing fate and fortune as warring concepts. They are not opponents. They are the two defining poles of the field of play. Fate is the hidden architecture. It is the constraint, the laws of physics that hold the structure together, the genetic code that sets the boundaries of possibility, the geological currents that dictate where we are born. Fate determines the size of the board and the initial rules of the game. Fortune, however, is the random distribution of the pieces at the outset. The roll of the dice in the dark, the unpredictable encounter that alters a lifetime in a blink. To live in the synthesis is to understand these boundaries. We cannot dictate the currents of the river that carry us, fate, nor can we control the precise moment a fallen branch knocks us off course, fortune. But if we are not absolved of agency, where does our true responsibility lie? It lies in the vast, consequential space between the predetermined structure and the random input. That space is not freedom from consequence, it is the freedom of intention. Our ultimate liberty is not the power to choose what happens to us, but the irrevocable power to choose how we respond to what happens. We are the meaning makers. The river flows regardless, but we choose whether to drift passively, paddle against the overwhelming force in futile defiance, or build the sail that harnesses the wind that chance provides. We select the intention, we structure the interpretation, and in doing so, we define the inner architecture of our own experience. Existence is a composition. The structural harmony is determined by the laws of physics and history, fate, and the timing of the performance is often dictated by accidental cues, fortune. But the melody, the spirit, the unique resonance that echoes into the future, that is the signature of our consciousness. To live responsibly is to become the hidden architect of our own meaning, weaving intention into the grand, indifferent design. We are not simply subjects of the universe. We are the conscious act by which the universe attempts to understand itself. And that profound understanding demands action, shaped not by the certainty of a predictable future, but by the courage required to navigate the beautiful, terrifying, and utterly necessary unknown. Comment.